This series will help you create cool physics simulations in Blender. Whether you are into physics experiments, having fun, or just using simulation for work, Blender is great for this. But I think Rigid Body is a little bit underrated. Maybe because there are not many good tutorials on YouTube. Just have a look to one of my most respected Blender channels out there, Polyfior. If he's doing this to simulate a simple pendulum, but I'm not entirely sure what was his intention, but if he wanted to create a pendulum simulation in Blender with rigid body, is very easy. But don't get me wrong, there are good tutorials on YouTube, like Mr. Chip's playlist on rigid bodies. But I think I can make a big contribution to the Blender community. That's why I wanted to create this series where we are going to explore Blender rigid body in depth. And I'll do my best to share what I know, so that you can go from beginner to advanced. So, do you want to learn Blender rigid body simulations?
Yeah, then I am your master. Okay. Don't cry.
So I'm in a brand new scene of Blender. And what I'm gonna do, I'm just gonna duplicate the default cube. We're not going to delete it for once, because I want to do just a quick simulation to show something. So we select all our objects, and then to set up the rigid body, we just need to go to Object, Rigid Body, Add Active. It will make all the selected objects active, so they will fall with the gravity. But if we want these objects just to stay stationary, so we put one of them as active, we go to the Physics tab, and then by pressing Alt and click, we make this object passive. And if we run the simulation, we can see how the active object is the one that follow, and the other one are obstacle. Here we can see this orange line here, that's the cache of the simulation, that we can move back and forth to see how the simulation behave. But as soon as you change something in the simulation, the position of this object, for example, we lost the cache. And we can't run it from here. It needs to be run from the beginning. Now, if we run it from the beginning, we can see that now it's behaving properly. That's what we wanted. And well, I'm gonna use this scene, this simple scene that I have here, to explain about the collision boundaries. By default is convex hull. Convex hull is like a shell that surrounds all the mesh that we have inside the object. I'm gonna do a quick example here. If I go to edit mode and I duplicate the cube, the convex hull is some sort of shell that surround the whole object. We can see this better if I run the simulation. So you can see how it's interacting in this, like an invisible shell. To illustrate this one better, I'm gonna duplicate this object, right click, go to isolation view, get rid of the rigid body property. Now this is just a simple Blender object, and I wanted to do is go to edit mode, select everything, go to mesh, and do convex hull. Now, as you can see, with this tool, we can do a convex hull of our mesh. But I wanted to be able to see through, so we go to displays as wire. Let's get out of the isolation view. And now this object is not a rigid body object, so it won't follow your gravity. But what we can do, we can take the one that is using the rigid body properties, select this one after, make the active the rigid body object, and then do parenting. Okay, now we can visualize better how the convex hull is for this example. And if you are asking why is acting so weird that is instead of keep falling in this way is doing all this, I don't know, acrobatics, and it's because if you see the center, the origin of the object, with I'm talking about not of the visualizer. Let me just hide that one. The one with the rigid body properties. The origin represents the center of mass. So if this object is 1 kilo, the 1 kilo force due to gravity is in this way. That's why when we do the simulation, the weight is at this point. If you want it to be like, let's say, more accurate, you can press or right click. In my case it's W because I use right click select, set origin to center of mass volume. And now the mass or the weight of the object is here. Now when I do the simulation, see how it behaves as we were expected. If we bring back the convex hull visualizer, we can see how it behaves. Now we don't need this one anymore. This one, a sphere. In this one way, yeah, we can visualize how the collision boundaries of this object is, and it's basically an sphere, and the size of this is done by the width, that by the dimension of the object. So if we go to edit mode and change the size, the sphere will be the size of that object, and is driven from this point because again this is the center of mass of this point. So we go to center of mass volume, and now it goes to the middle, and we can see that is basically a giant sphere. So the other options are a box, which is like the boundary box of all the size of the objects. Cylinder, well, the rest, yeah, it's just by the name. There is nothing more to it. This one, compound parent, I love this one. Well, should I talk first about mesh? Mesh is good because it reacts to whatever the mesh is. As you can see, the object is going through the obstacles and it's just reacting to the mesh itself. The problem with these mesh collision boundaries or collision shape is that it's very computing consuming. If you have too many objects and you set up all your objects in mesh, it's gonna be a nightmare. It's gonna take ages to simulate something that could be simply used by using the convex hull or cube or compound parent. So compound parent, I love this one because let's do something. So if let's say that we have another cube here or whatever, this one doesn't matter. I will tell you why. So let's separate everything by loose part. Now we have 3 different objects. Let's put the origin to the center of mass. I'm gonna set up, this is gonna be like my parent object. I'm gonna set up this one to compound parent. These two, I'm gonna set it up as cube because they are cubes. And now what I'm gonna do, I'm gonna parent those 2 cubes to this one. Alright, see, this object is gonna behave like it was like in the mesh sort of object. Let's move this one a little bit more. But the one that are like interacting with the environment are the child, not the parent. The parent is basically is like a placeholder. It's not doing anything. But this approach is better than the mesh because it's better for computing time. It's much quicker and it's more stable. As you can see here, it's working fine. And by setting up the shape of this one as cues, it's gonna make it even easier. So other thing that I would like to point out here, that you can go to the Scene Property tab, and in this one you have the rigid body options. This one gives you the speed, so you can even animate that one. You can go like full speed here, but then you want to go like slow motion here. So you can press I, go to another frame, and then put it 0.5. So let's see. Boom, and then going slow motion until you change the speed again. So that's one thing about that one. And then we have here the sub-step per frame. Just a quick parenthesis to talk a little bit more about the sub-step per frame. What we see here is just essentially a wall and a projectile. I'm gonna show you later in the video how to do something like this. And as you can see, the projectile just bounces against the wall. That's what we want. But if we change the sub-step per frame, let's say 1, then see what happened. It goes through. And it's because Blender is not doing the calculation quick enough to understand or to realize that it's a wall there. So it's just for you to take it in consideration. If your animation is super quick, you might want to put this number up, but take in consideration that it's gonna be more computing intensive. And the solver iteration is about the constraints. So constraints are a totally different word. So let's play a little bit with the constraint here. Let's delete this object. If we go again to the physics tab, we have this box. We have like a box. Now let's do a connection between these two. You go to object, rigid body, and connect. So you can see in the connect rigid body menu. Let me turn off this. So you can see here, we have a fixed connection between them two. And if we press play, you can see that they are basically behaving as they were behaving before. And you might say, well, I don't want to use the parenting. I can just use a fixed connection between a bunch of objects, but again, that's more computing consuming. And the connections itself, they are a little bit flexible. It depends of this solver iteration. If we make this number bigger, the one at the bottom, then the connection, they stay more rigid. I would like to illustrate that one quickly. So let's make these two 10, 10, 10. Let's go here and maybe delete all this object. We don't need the camera. We just need this object. So I want to illustrate how by changing the solver will change the connection. So let's make this one animated. And let's duplicate this one, this one, this one. Maybe another one more. So now we want to connect all these objects. We select them, go to objects, rigid body, connect. But here in this menu, we can choose a location and a connection pattern by change by distance. Okay, now this this connection is connected to cube 1 and 5. So cube 5 and cube 1 and so on. And now what I want to show you is like all this should be connected, right? And it's a fixed connection. but they are a little bit flexible anyway. If we press play, remember this is animated, this one won't move. These are free to move except for the constraint, and this one is free falling cube. So if we press play, see how there is some flexibility even when they are fixed connection. So to improve that flexibility, we can increase the solver iteration, and now it's more rigid, but this is more, again, computing consuming. If we send it all the way to back to 2, now they are super flexible. They actually behave like some sort of a string or a spring. All right, so let's go back. Let's put this one to 10. But even each of the constraint, you can change, you can override the iteration. So you can have the rest of the constraint driven by this value, or you can select each or the one that you are interested in and make it more rigid. You won't see much different here because they are all connected, but this one is being more rigid than the rest because we override that iteration. Now let's say we want to explore more about this type of connection. So let's delete all this except for the last one. Let's play a little bit with this one. So if we make it point, this object is gonna rotate freely around this point in any direction. So if we press play, you can see that it is bouncing because there is no more other object to interact with. But we can do something fun here. We can select this one, duplicate this one, and remember this have to be animated. And then if we press play, we can then move this one, and see, it's like a piñata. We can play in real time with the object and the connection, and you can see here how the connection is behaving. It's moving freely all the way around. The point connection, it have 3 degrees of freedom, which is the rotations. Then we go to hinge. Hinge is gonna give you 1 degree of freedom, which is the rotation in Z. How do I know that? Because if you see here in limits, it gives you a possibility to set up some limits in the Z angle. So that means that everything else is just locked. What I mean about that, so we press play, and then if we move this object and try to hit that one, look how it's moving. So it's just rotating in Z. It's not moving back and forth, so 1 degree of freedom in Z. So that's the hinge constraint. Now we move on to, by the way, I'm using right click select because I think just be able to select something in box select something like this is very useful. And plus, it's better. I've been using too much this finger. Don't ask me why. Anyway, now we go to the slider. So, see in the slider, if we want to see how it's moving, we can just see the limits. So it's asking me to put some limits in X. So that means that it's free to move 1 degree of freedom, but in X. If we want to check that out, we just press play and then move this object by hitting it. I was trying to play ping pong, but I couldn't. Let's see if I can do it. G, boop. Oops, that was too hard. But well, you got the point. It just can move in the X direction. Now, let's go to the next one. Piston. Well, this one, again, you can see what is going on here. So it's free to move in X, in angular, so it can rotate have 2 points of freedom, so it can rotate like this, and it can move at the same time like this. So let's see if we can show that one in a live demonstration. So if we push it slightly, so it's moving. But now we want it to rotate. Let's put it here. Maybe let's put it here and see how it will rotate. Boom. So see, it can move in Z and rotate in Z. That's piston. Another one we can think about piston, we have generic, which this one basically, it has freedom, 6 degrees of freedom, can do anything, can move, rotate, translate. But the point of this one is to set up some limits. So depending on what you want it, let's say that you just want this cube just to move around the YX plane. What you need to do, you just first lock all the rotations, press 0, and then in Z put the limit to 0. So now this object, let's set up our cube to demonstrate that one in a better location. Now we can move everywhere. Well, it can rotate, but it has like some sort of a slide. It's just going through the plane, through the XY plane. It's like moving in XY plane. And when you do the G shift Z, it's like moving this way. So this one is very useful. Generic, because you can set up your own constraints. To illustrate all these constraints, I set up this scene here where this object is animated. It's gonna go and hit all those real body simulations objects. So we can see that the first one is fixed, so nothing happened. The third one is point, so it will rotate in all these axes from this one. This one is hinge, so that's why it's rotating like that. The slider, we can see how the slider just move in X, and the piston will move in X and rotate along X. And for the generic one, I just have the generic one in XY. So we can see the simulation again, goes, hit, rotate, push, rotate, slide. So 3 degrees of freedom, 1 degree of freedom, 1, 2 degrees of freedom, and 2 degrees of freedom. Okay, now is the turn for the motor. This is the third time that I record this one. I forgot to play record before. And I didn't mention about the motor in my first draft. So let's talk about the linear motor. The motor works in the X direction. So we need to rotate this one 90 degrees. Let's put the X up just to show you what is happening. And to make sure to know what is the front of our cube, let's grab the top face and scale it down a little bit, so we know in which direction the object is pointing at. And let's run the simulation. Okay, we need to put this one animated or passive, it doesn't matter. Let's run the simulation. Okay, it's coming down because the speed, the direction of the speed and the impulse. So let's bring the impulse to 100. Okay, so it was actually pointing up, but it was so weak that the weight of the object, it was bringing it down. It was stronger than the motor itself. So now it have the impulse enough to push it forward to the X direction, And when I wanted to show you something, is like, let's change the name of this one to floor. And this one we can change it to, I don't know, rocket. And now let's add another cube. And we put rigid body to this cube. I wanted to show you something. And let's offset it a little bit. Okay, now we have this object. And if we run the simulation, what I wanted to show you is that the object, it has the motor attached to it. To illustrate that one better, let's make a quick cylinder here. Let's move it, let's position it to the empty. Go to edit mode, scale this one. Grab the top face, the bottom face, scale it down. And then we parent this object to this one object. I have to move because my microphone doesn't let me see the keyboard, and then we run it. So what I wanted to show is that the motor is pushing, is here actually, and it's pushing the object down 1 meter per second. And that's why it's not falling due to gravity, because it's holding it back. If we change the speed to something bigger, let's say 50 per second, and we run the simulation, and so see how it actually got out of control. But now you can see better that the motor is actually there, pushing the object at all time. We can maybe, let's make it with less impulse, maybe 50. Let's see what happened with 30. Boom. Okay, now it's not going that crazy, and it's acting more like a proper motor. But what happened now if we change the order? If we put floors first, and then if we put rocket in the second position, it's important here to change the direction of the velocity. Now it's minus x. But see what happened. It's still going up because we changed the reference, the object reference. But what I wanted to show you here is that at this point, the motor stays here. So let's do Alt P, clear parent. Let's rotate this 190, 180, sorry, 180. And look, it's like this force is always here pushing that object up the whole time in the same direction. If we go, maybe it's too quick, let's change the speed maybe to 20. So see, now it's pushing all the way in the same direction because our reference object is the first one, is floor. But before, rocket was the first one, and then the motor was always attached to the object. That's good when you want to simulate. I have some simulation there with a rocket going like out of control. But yeah, it is important to do that. And for the other option, which is the angular, it's gonna just rotate in the x axis. So but it's falling. So there is something that I didn't mention before. If we uncheck this one, see, because this is check the objects that are connected to each other, they don't collide. But if we uncheck that one, they will collide to each other, and see how the motor is just making this one rotate. Let's put more impulse here, like 100. But you can see how it's moving. And of course, if you don't want this one to get out of that axis, you have to add another constraint, which we know what it is. It's gonna be, let's put it in a different location. It's gonna be the hinge constraint. Now it's gonna stay there. And maybe let's put more speed. Target speed 10. And now can be like a blender inside Blender. And the next one is generic spring, which is basically the same, but the only difference is that allows you to add some bounciness. I don't know if that works, but it can grab you some bounciness in some of the direction that you want. So let's say that we want to make a simple object with a spring on top, and then another object is the top of the spring, and we want this object to fall on top and then just bounce like it's bouncing in a spring, right? So on check animated, and what we want to lock all the rotations. So limits all the rotation to 0, that's fine. And then we actually wanted to move in Z. We put this one, but we don't want it to move in XY. So we wanted to move it in Z. 1 second here. Just notice that it's not exactly on top. Going back to this one. For the spring, we don't want any spring in the angular direction. We want just a spring in Z. So we go to Z and just check it. Let's leave this by default. And probably, yeah, I think that's not gonna work because no. So you can see here that it's acting like an actual spring, but it's at the beginning. It's going down because this one has a weight on it. So if we want more damping, it's gonna make it like move, like go to, how you call it, to the stationary position faster. So more dampening, it's gonna make it like, I don't know, imagine that it's going through honey, that is making it slower to move. And if we put it less, it's gonna be like a crazy, never ending bouncing spring. All right, now let's bring this one back to life, and then let's see how it behaves. See, even I can let's make it even less damping and maybe stronger. And you can see. And if I make this one heavier, let's say 5 kilos, now oil is moving more, and this one can be, I don't know, like a endless loop of bouncing ends and movement, like the eternal motion machine. Yeah, talking about the eternal motion, each object it has some dynamics. So this one is like, again, is like the dampening in the spring. More dampening have the object. I think we can set up something quickly here. Let's delete this, and let's do, maybe let's remove animated. Let's put the dampening all the way up, and let's make the obstacle track again. So this one has the dampening all the way up, and this one has the dampening by default. We can put it 0, it doesn't matter. So what I wanted to show you is that these objects, they are going to move very slowly, and this one gonna try to go through all of them. Well, you can't see much, but they are actually falling. And this is something that can be animated as well. See, like they are going in a slow motion in the same way, in the same environment. And if we put the rotation all the way up to probably 9, put 299. So you can see that now it's pretty funny. I really like it. Let's make more. Boom, 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 boom. See, it's like they are out in, I don't know, in some sort of liquid. And this one is like it can be like a bullet going through objects. So it's very interesting for me. Anyway, so that's the dampening of the object, and the object have collections. This one is, it tells you when you want some objects to interact to each other and when you don't. For example, if you want this object to go through this one, you can do something. You can change the collection of this object to 2, and now this object, it will go through that one, but then hit the rest. This is very useful sometimes. And the sensitivity, well, collision margin, that's, I think, self-explanatory. If we set it up to 1, what is gonna happen is that it's gonna be like a, no, 0.1, let's put 1. It's gonna be like a 1 meter in between before they collide to each other, which is not happening. Maybe it have to be in mesh. Yeah, it have to be in mesh. It doesn't happen when it's in box or any of the rest. Probably convex hole. Convex hole. It happen in convex hole. Okay. So one important thing to take in consideration when you do simulations is that the scale, it should be set up to 1. So if, let's say that you are grabbing this one and make it bigger, and you run the simulation like that, it will work fine, but at some point, it's gonna give you some errors. Or even if you put it in box, yeah, you might get some errors. So what I do, I always go Control A and then apply scale. This one, let's put it back to our first collision. And this one will give you better simulations than if you don't apply the scale. So it's important to apply the scale when you are doing physics simulation. And I know you are gonna think, oh no, Blender is gonna crash when you do simulation, and it's yes. But don't worry, when that happens, you just need to go to Files, and in Files, there is something called Recover. So you can go to Autosave, and then you will see there is this file that is, it doesn't have a name. This file, it was saved today about 1 minute ago. You can go to the preferences and change how often you want this autosave to happen. But if you are working, I think it's usually 5 minutes, but if you are working and something crash, you just go to here, recover, autosave. And that will save you a lot of work that you don't need to redo. Now, this setting, let's play with this setting. Now let's bring this one back to normal, which is 0.4, it doesn't matter. We put it here, and then we are going to make this one our floor. So press A, no, edit mode, A, scale Z, scale everything but Z. This one now is gonna be passive. And this one, so we're going to leave the friction as it is, but we're going to change the friction of that one. And let's spin it a little bit. And see, now because there is a lot of friction, they don't slice as easy as you would expect. Well, you wouldn't expect that one because we put the friction all the way up. But if we leave it by default, the objects will just slice down. So that's it's not a secret, it's not a something very hard to understand. Now the bounciness here. In this one, I actually have a little problem with this one, because when you set it to 1, nothing happened. Well, you can change, because you need to change this one too. Let's change, because the bounciness is 0. So let's put the bounciness to 0.5, and it should bounce. It's bouncing, but it's not bouncing as you expect it to bounce. It's doing the job well. Let's do something. Let's delete all this. Let's add an sphere, and then put this sphere here. This sphere is gonna rigid body. You can set up the rigid body from here. You don't need to go to objects. You can do it from here, and then let's add bounciness. So let's put 0.8. This one is 1. This one is 8. And then when it hits bounce as you expected, all good. But then it didn't keep bouncing properly here. And this is a little problem with me, because Blender 2.7, the old Blender, it has a better bouncing capability. Okay, what I want to show you here is how the difference between Blender 2.79 and Blender 3.6 is. These are just two projectiles that should bounce again the objects, and see how they behave. So we can see here how it has like a nice bounciness, and they have the same properties. And now in this one, see how it doesn't quite, this one stopped bouncing, and that one didn't bounce properly, and both they have the same property value for the bounciness. So I think this one, maybe, I don't know, it could be easily fixed. I already report the bug, not about the bounciness, about another thing that I'm gonna show you later. But I think this one should be easy to fix, right? I don't know. I'm very naive. I know that Blender uses Bullet as a physics engine, but it didn't implement it properly in the later version of Blender. So if someone knows someone, or we can have a Discord channel or whatever you call it to try to fix this one, that will be very useful. This one is about the mesh shape. Well, for example, this one is just a plane that has a modifier in it. If we see the modifier like the wave modifier. And when you select mesh, you can go to the form. You can select the form, and then deforming, which means that the simulation is gonna take care about the deformation during the animation. So all these cubes that are part of the rigid body, they will fall on top of this plane and get moved by the wave. And this one is the same in Blender 3.6. So let's see how it works in Blender 2.79. So see how the wave moves the cube and all the objects properly. But then when we do it in the Blender 3.6, it doesn't happen. I already report this one, but they haven't fixed it yet. I hope one day they do it, but I will happy, I don't know, to give it a crack to this one. I'm not super good at coding, but I think if that used to work in 2.7, it should be easy, right? To make it work in 3.6. I don't know. Just let me know what you think, and if you know how to, fix this one, just I don't know, explain how to do it, and we can do it together. It bounced a little bit, but not as it should. And now if I put it to 1.5, it will. Nah, it's still not working. Now let's put it to maybe 3, see what happens. It should go higher. But now at this point, it will never go to rest. It just keep going and going forever. So that could be interesting if you, I don't know, set up a bunch of objects and all of them have like a lot of, I don't know, yeah. Maybe it's too much because they just went down like crazy, but let's change it to maybe 2. See what happened. Boom, 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 boom. See, you can even make a fusion animation about how atoms hit each other and make a fusion, nuclear fusion. All right, the other thing that we can play with is with the activation. Okay, another quick parenthesis here to talk a little bit more about the activation. So what we see here is just a cube with the dampening all the way up to 0.99. The velocity linear is set to 2.14 meter per second. So what is gonna happen is that when it reaches this number, well, an average of that number for the previous 50 frames is gonna go to a stop. Here we can measure the speed. This is using a script. I can show you how to use the script later if you are interested. And if we press play, see, the cube never reaches this speed. So it should stop by now, right? But it stopped after 50 frames, for example. At that moment, it stopped. Now the other cube is gonna hit it. This cube, they just have the dynamic keyframe at this frame. So I start falling. Now it's gonna hit the cube. So if you can see, the cube is now it's become like a normal rigid body. But then when the speed go below 2.14, then it's gonna go to a stop after 50 frames, more or less. You can see the example again happening. And I have marked this one, so you can see the speed here goes under 2.14, and then here is where it stopped, again around 50 frames. And then in this one goes under 2.14, and then at this point is when it stopped. So that's just a quick demonstration. Now, okay, in this one it's the same, but it's about the angular velocity, and this one is tracking the speed of the angular speed of this cube, which is animated, and then from this point it's going by physics, so it's gonna fall and hit the ground and slow down. And at the moment, let me set up the speed to 5. It says meter per second here, but that's not correct. It should be radians per second. Anyway, it still worked. So if we run the simulation, we can see how from the frame 145, it goes under 5 radians per second, and then after about 50 frames, it should stop. If we change that number, let's say to 3, and run the simulation, so 3 happens at this frame because I measured it before. So it goes. It meets that condition, -3, and then it stops. So for the cube to stop, it have to meet these two conditions. The linear velocity and the angular velocity have to be under whatever the value you put here for the object to go to a complete stop. So what is going to happen here, that this object, they are not going to move until they are hidden by something else. So they hit, and now they start moving. That one is interesting because that one is very time saving. when you want to maybe destroy a wall, you can set up this one. So the wall is not, the bricks of the wall are not interacting to each other until they are hidden by something. All right, we can do that exercise. Let's do a projectile. So that's gonna be the end of this video. Let's make a projectile. And for that, we need this one to be animated. We need to animate that one. This keyframe, let me select, delete that keyframe. So let's see. We want the object to be here in the first frame. Now in the frame number 10, we want this object to be here. Key location available. Now it's moving. Boop. That's what we want. But at this point, maybe frame 7, we can disable the animated property. So well, in the frame 8, disable, going back, and then we have a projectile. Yeah, nice parabolic motion. So let's see the location. Let's have a look in the location. So cursor to selected. So the ball's gonna reach that point. So I just want to move this one, because what I wanted to do, I want to make a wall here out of cube, a big wall. It's important as well. Let me snap this one to vertex, because I want it to be exactly on top. And we allocate this one here. Now maybe go and make it a little bit shallow, and here something like that. Okay, I wanted to touch exactly this one. Set up to 1. Now we go to array. No, not in X, in Y, and we want a bunch of these things. Now we make another array, but at this time is in Z1, and to make it look like a actual brick wall, we can set up this one to 5, and now another array in Z 0 1, and let's make it, I don't know, something like that maybe. And we should probably move this one somewhere around here, because the trajectory of the ball is gonna be something like that. Okay, now we apply all these arrays. Go to edit mode, P by loose parts, get out of edit mode. Now we put the origin, which is gonna be the center of mass of the object, on each center of the object. And if we go back to our physics tab, so see, this one doesn't have any of these one have the rigid body property, and you are not going to do it all of them by here. So all of them you can do it by once if you do rigid body active. But this is the part that I was saying, that is gonna be better computing time if we check this one, press Alt, remember, and check this one, and make sure that all the objects have the same property check. And now we can see how much fun we can have with rigid body. So the projectile is coming, and boom, hit the wall. That is amazing, right? I know it's not. What we can do is to put more weight to this object, maybe 50 kilos. It's gonna, I'm coming like a wrecking ball, destroying everything in my way. See, now we are talking. Now we are talking. There is something I love to put this one in cavity and then both, and maybe make change this one to this. Yeah, better lighting. Now let's see. Boof. Chuxy. Isn't it amazing? Huh? Well, I think that can conclude this video. So that was the end of the video. I didn't know it will take me a couple of days to finish it, and it will be that long. 50 minutes is a lot. But next video, hopefully, it's gonna be shorter, and we are going to try to make something like this. So I was playing a little bit with some cards and simulation, going around these loops. What you see here is just changing the speed of the animation to make it a slow motion, and from the beginning, everything else is driven by rigid body simulation. And the cars, they actually have some sort of springs, so that you can see it has like shock absorbers, and you should be able to do this because this object is just a mesh deform, and the car is just half wheel with the hinge constraint. But I'm gonna make a tutorial about this one the next video. And if you want something, I don't know, that I should you want to learn more, I can show you how to do it. Just let me know in the comments, and if you like this video, I don't know, let me know as well in the comment, because I don't know if I'm good for this. It took me a lot to make this video, but I hope it will help you for your physics body journey. See ya.